carry research and telecommunication equipment into the Earth's atmosphere is one of the most expensive and time-consuming challenges for large space organizations like NASA. The extremely high costs of each satellite launch have led to the use of zero-pressure balloons for research and meteorological purposes for the past several decades. But there is a serious problem in the continuous flight of zero-pressure balloons, and that is the great loss of altitude due to the leakage of helium gas. The main factor in the continuous loss of altitude of zero-pressure balloons is the changes caused by the expansion of the helium gas and its leakage during the day due to the increase in the temperature of the balloon envelope by sunlight, and again the decrease in the volume of helium gas as it cools and contracts at night. When the balloon envelope reaches the end of the troposphere and the beginning of the stratosphere, the condensed helium gas in it experiences an increase in temperature due to exposure to direct solar radiation. This causes the gas molecules to spread out more and their volume increases inside the balloon envelope, which ultimately leads to an increase in pressure and gas leakage through the control regulators. And as it's clear, gas leakage is the main cause of the loss of altitude. In such circumstances, due to the problem of reducing the altitude of NASA stratostat balloons and the inability of the balloons to remain in the atmosphere for a long time, government organizations and space companies must seek alternative solutions such as launching satellite rockets. However, due to the high cost of each low-orbit rocket's launch, it's not easy to continue carrying out scientific and research projects. These problems led me to create the idea of building a zero-pressure balloon that is not affected by the heat of sunlight, so that it has the ability to send heavy cargo without losing altitude and has the ability to stay in space for a long time. In other words, my idea is an alternative solution to using lifting rockets so that space cargoes can be sent to low Earth orbit with less cost and risk. I use a special fabric called heat-reflected fabric, which is made of fiber material that reflect heat radiation. The fibers of this type of silver-colored fabric, while being very light and weight, have the property of completely reflecting light and not penetrating heat. This cover is high quality and resistant to high temperatures from solar radiation and also able to withstand extreme heat of more than 2000 degrees Fahrenheit. To avoid adding weight to the balloon, I use heat reflecting panel on only one side of the helium envelope. I also use 6 lightweight controllers equipped with light detection cameras. These tiny cameras are capable of continuously tracking the sun and are connected to the electric actuators by a smart system to keep the balloon balanced. With any deviation in the direct sunlight, the camera's electrical sensors sends an actuation pulse to the electric actuators. After receiving this pulse message, the electric actuators apply a mechanical shock in the opposite direction of the light to return the balloon to its previous position. This mechanical shock is created using the pressure caused by the collision of the positive and negative electric charges. In fact, by adding electrical voltage between two plates with a high voltage difference inside the electric actuator's box, a small control explosion occurs, which leads to the movement of the electric actuators in the opposite direction of the spark. electricity required to generate the voltage difference in the electric actuators can be provided by the solar panel mounted on it. Using this system, we can ensure the continuous orientation of the heat reflecting panels towards the sunlight for a long time. This zero-pressure balloon, with its unique design, does not lose altitude during the day or night, and in addition to being able to reach higher altitude in the stratosphere, it will also have the ability to survive longer missions in this layer. My name is Pourahmad. Please respect the copyright of my idea, and you can contact me via email in the credit list at the end of this video if you're interested in purchasing the copyright of my idea. Thank you for watching.